Hello, everyone. So I will introduce you a extract section of data analysis, particularly, focusing on quantitative data analysis. So here, let me bring out the slides. Okay, so this is an extra section prepared for dissertation module students. So there are two parts in this section. The first one will be reviewing some key concepts that was already introduced in the last lecture. And I think it's important to review and renew your memory about quantitative data analysis before we begin to offer an example, look into an example of data organization and to use data analysis. To analyze data using Microsoft Excel. So let's start by reviewing key concepts on quantitative data analysis. First of all, it's important to know that there are two different type of, or basically two major different type of statistics. One is descriptive statistics, and the other one is inferential statistics. And at undergraduate level, if you would have collected some quantitative data, you'll be required to do descriptive statistics. So this lecture is basically, focus on this part at descriptive statistics, which is to describe responses to the independent and dependent variables, and to describe the basic features of your data, the overall figures of your data. So then you can provide simple summaries about the data that you have collected using maybe, bar chart, some visual tables, or line charts to present your data. Well, and inferential statistics, basically this is to test, differences of the data between groups. So your outcome variables, which are dependent variables, or the differences between different groups, for example, gender or ethnicity or different conditions. Excuse me. And in this case, if you want to compare differences between groups, then you can use t-test or ANOVA. But if you want to test relationships, then relationship between two different variables, for example, relationship between attendance, engagement, and performance outcome, then you want to see whether there's a positive relationship between them or not. Then in this case, we can use correlation tests to analyze the data. So these are inferential statistics. But for you, and for today's section, we'll be focused on descriptive statistics. Once when you collected your data, the first step is to be sensitive in understanding these numbers presented, collected in front of your computer. So some data, they are nominal and categorical data, such as gender, ethnicity, and color, nationality, for example. With this type of data, you can only count frequency. It's not meaningful to count average of this type of data. The second type of data, a number, is ordinal. You can do ranking. You can count frequency and arrange them in order. Third and fourth type of numbers are interval. and ratio. With interval, it has the same distance, the same gap between 1 and 2, 2 and 3. Such as grades, income, or someone's age. Or ratio, which has a feature which is that it can be defined by 0 point. For example, 0 in height, 0 in mass, 0 in time to a task. So this is ratio data. It's continuous type of data. With this type of data, we can do so many different we can play with them in many different ways, such as counting frequency and calculating means and ratio and percentage. So the purpose to do descriptive statistics will be would be relevant to figure out. So because you want to know the bigger picture of the whole data set, it's quantitative data, you want to know the overall picture of this set of data. So we want to know the location. Sometimes we call it measures of central tendency. We want to know where is the majority of the data located. And I also want to know the spread, how widely spread of participant responses. So with the location, it's important to know these 3 different features. The first one is mean, which is the average of all values in a distribution. With mean, it's vulnerable to outliers. Outliers means extreme values in either end of this distribution. For example, if we take mark, grades from 0 to 100, for example, the outliers will be, those approach to 0 and approach to 100. So these are extreme cases. So mean is not sensible for us to identify those outliers because it will be only a few cases. With median, the second one is the midpoint in the distribution. And with the median, it helps us to reduce the impact of some very big values. So we know what is the big, the highest point, the most frequent value among the data that you collected. Oh, sorry, that's the midpoint. Midpoint is the middle point. So the first half and the second half of the distribution. So you figure out the middle point from the lowest mark and from the highest mark to count from in the middle. So that's the median. The third one is mode. The mode is to value the highest, the most popular and most frequent responses to identify that figure in order to figure out the location of distribution. And then for the spread for a distribution, it's important to look at the range. So what is the lowest mark? What is the highest mark? Lowest mark could be 20, highest mark could be 85 or 86 or 87. So that's the range. And then there are another 3 different key concepts here, which is measurement error, standard deviation, and variance. These are concepts that can help us to understand the spread of a distribution, which I will introduce in the coming slides. So to know the location of the distribution, these are 3 figures that can help us to understand why it's important to know the mean, the median, and mode. So let's look at the middle one, which is normally distributed, which means that median and mode and means are all in the same point. So the figure is symmetric. So you have half of the data located in one side and another higher mark of another half located in another side. Right? So it's symmetric. It's we call these normal distribution. But some data might not be normal distributed. For example, in A figure, it's called negatively skewed. This means that the mode is approach to higher end. For example, taking grades, for example, the mode could be, located in 70, and mean is perhaps maybe 60. It is possible that majority of, for example, 100 students, majority of students are, more than half of students are above the average, and then some very lower mark, then, poor the average means down to the lower end. And with C, which is positive skewed, it means that it's a opposite example, and you have a lot of marks being located in the lower end, and then some very higher mark pull up the average means. So this is called like normal distribution. So we know that a function that represents the distribution of many random variables as a symmetric bell-shaped graph, we call this normal distribution. The location is depending on its mean. What does this mean? If you look at this figure in here, all of the figure of these three different lines here are located around its mean, which is 15. The range is between 0 and 30, but all is located near, around the mean, around the average. And it's symmetric, so the median mode and means are all located in the same figure, in the same value. There is only one mode, only one peak. And then now there are three different lines in here, and here representing the first line, blue one, is standard deviation 1, representing standard deviation 1. The second line is a bit lower down, and then the green line is the flatter and wider spread figure. What does this mean? This means that the variance of the data that you collected among your participants, are different. So now let's move on to talk about what do we mean standard deviation. Standard deviation is relevant to this concept about the spread of the distribution. And to know the spread of the distribution, we got to know measurement error. For example, in your questionnaire, you might have an item, a question listed such as, to what extent do you agree that the following statement, I'm trying to understand the meaning of statistical journal articles. To what extent do you agree? So 1 is agree, 5 is disagree. So the answer that the participant may give from one day to the next day may vary. So this is a common understanding and pre-assumption that many students will have about how do we know that one response is accurate. So situation like this is called measurement error, and powerfully statistical analysis can calculate such measurement error. So we call these error variance. So it refers to the extent of the variability in the test scores, in those values that you collected on your survey. To what extent this variance is attributed to the error rather than a true measure of behaviors. So we have observed score, which is the actual score obtained from your data. And then we can calculate the true score, which is the stable score. And then we can also calculate error variance that is by chance, that is because of, it could be based on random error or systematic error. So because there are error variants in the data that we collected, so it's important to calculate, so what are the overall variance? So what are the overall standard deviation, standard variance, standard deviation from the data that you have collected? So sample variance means that it's a figure, it's a value that represents the spread of a distribution within a set of data. So the sample variance is the square of the sample standard deviation. So what is standard deviation? It means that the spread of the data from the mean, how widespread is your data away from the mean. So it's a numerical value which used to indicate how widely individuals in a group may vary in their responses. So if individual observations around the whole group is great, it vary greatly from the group mean, then it means that the standard deviation is going to be big, and vice versa. So if you observe that majority of your participants' response to a particular question are all gathered around the mean, it means that the standard deviation is small. So from this figure, blue line and red line and and green line, we will know clearly that the blue line refers to the standard deviation, which is very small, and the green line refers to the standard deviation is very widely spread. So that's why it's important within descriptive analysis, while you are presenting your results, if the data that you collected is interval and ratio data, which are meaningful if you calculate its mean, its average. And it's also important that you offer standard deviation along the mean. And it's actually very easy to calculate using Excel or other tools such as SPSS. And while you are presenting your data, your results, ideally it's you could present your data, numerical data, in table form, such as this table presented in here. It's important that you label the table, give table a number, and give your table a name if you have more than one table or more than one figure. So it's important to give it a label and a title, and then you present it in a systematic way. So once when you present your data in a table, you don't need to describe them in texts, in words, because it's clear to present it, this table. It shows everything, clear to your readers. But if you want to highlight the major differences, you could highlight using tests, suggesting that method, among methods of praise, which each group prefers, will value the most. So letters home is being found, to be the most effective way to praise, and there there are many different perspectives, from pupils' perspectives, from parents' perspective, from governors' perspectives. From governors' perspectives, it will be through verbal. So you can, at once when you present the basics of your data, then you can start to outline those significant features, important points from this table, and to describing them in text when you're describing your data. Okay, the next one is bar chart. Again, it's important that you label it and it shows clearly, it would be good to put percentage in here as well. The next one, the last one is pie chart. This one is bar chart. So with bar chart, again, you create this and you label it, and then you put a text and title it. You can ask Daddy, please. So the next one is live graphs. So this one is quite powerful, because then you can separate your data into 3 groups, and then you can provide data from week 1 to week 6 if it's relevant to your research. So those are basic concepts of descriptive statistics and how you can present your data. And here is a specific example that you could use to organize your data. And I will show you how to do quantitative descriptive data analysis here. So in your survey, it's worth to mention that you will have your cover letter. I think you already done it. And then you have your items, which are your questions. And then you have your closing instructions. And then, and you did your pilot study. You identify your steps to administer your survey and to follow up. So, well, these mapping variables of the survey with your study is important stage, but it's actually important while you are planning it. Because we are linking the data to your research questions, so it's important to remind ourselves about these concepts again. So what are the key concepts of your study? What are the representations of these, these numbers in relation to your research questions and these key concepts? After you identify your variables, your key concepts, then it can provide you with a consistency of your research focus. It can link your variables to your research questions. It can determine how your data may connect to your hypotheses. And then you could, compare, and you will know how to analyze your data better. So there are different type of variables. There are dependent variables, which are something that you're interested, and it may depending on the independent variable, such as gender. There might be some confounding variables that you can justify and use to interpret your results that is not being listed within your key research questions. Okay, so for example, research question 1, it could be, is there a difference of academic performance between male and female among undergraduate education students? With research question like this, you are actually, asking a very specific type of test, which is called t-test. And the research question 2, it could be, is there a positive relationship between attendance and academic performance? In this type of research question, clearly you are using correlation to find out the result and to see whether it's statistical significant. However, we will explain more about how to conduct descriptive statistic analysis. So now there is an example, and this example is a questionnaire which would like to study individual students or a group of students' math and technology confidence. So there are 8 questions in here. The first 7 questions are mostly close-ended question. The third question is slightly open, but people will be just providing, short tests. And the 8th question is open-ended question, which means that you'll be collecting qualitative data. This just show you that you can combine quantitative data and qualitative data in one survey. If that's what you do, then you can cluster all of your quantitative data together to do data analysis in relation to your research questions. And then using your qualitative data to be, to either support quantitative data or using your quantitative data to support you to respond to your to support your qualitative data. So look into this questionnaire here. The first question is asking about age range. Second question, gender. Third question about which degree program. Fourth question about highest math level. There are 3 different responses in here. And fifth question, so 5, 6, and 7, these 3 questions about the confidence level. So these are the dependent variables, which are the key concepts that researchers would like to find out. So how confident are you at using computers, using Microsoft Excel, and how confident you are of your mathematics? Yeah. So these 3 questions. So now, important to code your variables before enter data into Excel sheet, and to differentiate your variables, differentiate to get to know your numbers, right? So whether they are categorical data or they are interval data. So for the examples that we provided in here, you can click this sheet in there, and then these will link to this table that I want to show you. Hang on. Okay, please bear with me for a second. I'm trying to show you this table in here. So let's look at this data set. All right. So that's the first research, that's first question. Okay, let's go to items in the questionnaires first. So there are 8 questions. The first question, age range. So there are 5 different age range. There are two gender at 2 levels. And then there are different type of categories of, degree program, but we are not interested in that one. Fourth is GCSE equivalent in terms of the highest mathematics level. Yeah. So you can see all of this data is, listed in items in the questionnaire in this sheet. And then let's look into the data now. So you got to remember which question and its responses and the code. Okay, so now we see the data. We now know age group. There are 2 codes in here. So you have participants. How many participants are there? There are 44 participants. So give them an ID. So anonymize your participants. And then you code these age group into 1 and 2. Okay, and then you code gender into 2, 1. But to be honest, because I'm more familiar with using SPSS, so the coding of gender into 1 and 2 is really beneficial and working very well when you are using SPSS. But when you are using Excel sheet, it's slightly dodgy, which means that you got to remember that number 1 refers to female that you recorded in here, and number 2 refers to male. And with age group, 1 refers to less than 25, 2 refers to 25 and 35. And then with the highest math level, we have 3 categories: GCSE and A level and university level. So let's come back to your data. So that's your age group, majority, less than 25 years old, gender, probably, you know, equal to which are probably equal between different gender. And then you have math level, you know, 1 to 3 at GCSE, A level, or university level. All right. So now you also have math confidence range from 1 to 10, computer confidence range from 1 to 10, Excel confidence range from 1 to 10. And your final open-ended, you know, question in your questionnaire. So you can organize your data in this way. Now, let's go back to where we want to analyze the data in here. So now to do your analysis, frequency, average, range, standard deviation are something that we are interested in. So how to do descriptive data analysis using Microsoft Excel? So first of all, we want to do these 3 things, okay? So we want to describe the basic demographic figure of your participants. It's important to let your readers know who are your participants. So if you know their age and gender, these are basic. So it'd be good to know how many of them are, you know, less than 25 years old, and how many of them are male and female. And how about how many of them in terms of their highest mark level. And we can do this using a pivot table in Excel sheet, which I'll explain later. It's also important to describe the outcome variables, which are the concepts that may link to your key research questions. So because our outcome variables, it's interval data, which means that you can calculate means. But once when you calculate means, which is, you know, you locate the distribution, you know, of your data, location of your data, but we also want to know the spread of your data. So with the spread of your data, you can use standard deviation to know how much variance are there, you know, in your data. So it's important to calculate and presenting both means and standard deviations of your outcome variables. So for example, I am just making these research questions up. For example, one of your research questions could be, how confident are students in mathematics, using computers and using Excel? Okay, so you can use your data to respond to these research questions after you analyze it. There might be other research questions that, such as research question 2, 3, and 4, that you will be able to calculate. You will be able to do descriptive analysis. For example, research question 2 would be, how different of the obtained math level between males and females universities? Yeah. So then you can use, again, pivot table or pivot charts using Excel. Or research question 2, how different the level of confidence in math, computer, Excel by gender? No, whether men and female, they are confident, their confidence level in these 3 different type of tasks might be different. And whether the highest math level might affect confidence of math, computer, and Excel. So now let's start from the first one to describe who your participants are. So let's come back to here. I already done the first questions about describing your participants already, but I can show you how to do it. So basically, we can come to your data to count the frequency of different age groups first. So to start, you select the item that you want to analyze, you want to count, and then you press insert there. So press insert and choose pivot table. There you select it, and then there is another up. You already selected the range of the data. And there's another choice that you can choose, which is, do you want to place the pivot table in new worksheet or existing worksheet? I want it to be placed in existing worksheet, like what I have done here. So I'm pressing here, and then the computer asks you, where do you want to place it? So I want to place it in here. Okay, so then you can see. So put it in there. So now there is a pivot table that you can see from here. Okay, so we would drag this into the value column. Okay, and because I want the row to representing different age categories, so I want to drag it again to make into different rows. And values here, you can choose. If you press the icon in there, then you can choose whether you want count or average or standard deviation, you know, yeah, or maximum or minimum. But here, because it's a categorical data, 5 different type of age groups, so we can only do count. So we choose count, and sum doesn't make sense for us. So we choose count here, and then we press OK. So then there's count. Yeah. And I want to do the same to gender. So I will demonstrate again. I show it in here. I select, data from first participant to the last participant. And then I press insert in here, press insert. And I want to insert pivot table. And I repeat what I just did using existing worksheet. I want to put it, in here. So press OK. And then I drag gender to here, and I want it to be, gender has 2 different values, 1 and 2. So I want gender to come here too. So again, I don't like sum, I want count. So I press count and I click OK. So this way, the computer Excel actually, calculating the the count for gender. So now here we know, there are, okay, so here so now we know for age range, I can come here to change E. So 1 equal those less than 25 years old. Yeah. And then 2 are those which are between 25, it's between 25 but less than 35. Yeah. So I know there are 41 of participants who are aged less than 25 among those 44. And I do the same to gender, count for gender. So that's the 1 representing female, type female, 2 representing, male, so type male there. Okay, so that's the first one. That's and you do the same to count math level. Okay. So now we've done the first one to describe basic demographic figure of your participants using pivot table. Second, to describe the outcome variables, the key concepts that you are interested in. For example, how confident are students in math, computer, and Excel? So look into the data again. So this is math confidence and computer confidence and Excel confidence. Because it's on a scale of 1 to 10, so I know it's an interval data, so I know I can count average. So I want to know the average and standard deviation of these three different confidence level. So let's have a look. What did I do in here? Okay. Okay, I think we need to do this like individually. Let's come back here. I forgot how I did it, but we can do it. Okay, so I think maybe I will come here again. I think I will select all these threes in here. Okay, I select all these three because I want to calculate its means and its standard deviation all together. So again, I use insert and I choose, I think I would choose, okay, pivot table again. So I have selected the range, okay, and I want it to be existed in the current worksheet, and I want it to be in here. So I click here, yeah, and I press OK. So now on the pivot table here, I have these three different items, three different variables, and I want them to be in row. I want them I want the values of, I have to drag one by one, value of math, and I want the value of competence, and I also want the value of Excel confidence. So math, computer, Excel confidence, but I don't want sum, I want the average. So I go to change the average for each of them. So go to change the average, okay. And then I change the average for the third item. Okay. So then in here, you can see a result in here, but I don't like it to be sprayed on the columns. I want it to be sprayed on, to be located on each different rows. So I put it in there. Yeah. So here are three averages of, these three different items. Now I do the same to another, to figure out standard deviation, and it's easy to do as well. So standard deviation, I select all of these data that I want, and then I press insert, pivot table. I want it to be in existing working sheet, and I want it to be in here, and I press OK. Yeah. So again, I do similar things, drag it individually, one by one, and there. Okay, and I don't want sum because I want standard deviation. So then I press standard deviation, STD, DVE, it refers to standard deviation. I press OK. I did the same to computer confidence level, standard deviation, okay. And I do the same to the third final item. And I did that. So then job is done, but I don't want the data to be located based on columns. So I put it in row there. Here you are. So I got the average and standard deviation of these 3 different items. So I done the second research question. The first research questions: how confident are students in math, computers, Excel sheet? And then your research questions might be then move on to think about how about gender, whether gender might differ in something. In first of all, for example, the first question refers to how different of the obtained math level between different gender university students. So now let's do this. Okay. So first of all, I identify variables. I just said how math level differ between gender. Okay. So I am going to select my data again. So I select all of this data in here. I can ignore degree when I do the calculation, when I choose it. But here I choose both gender and math level. Okay. And then I think we use insert again. Okay. We use insert again. And here, I would like to have the choice to either presenting my data into a table or into a chart. So here I use pivot chart because this offers me 2 choices. And because it'll be more complicated, so I want it to be happen in a new sheet, to be generated in a new worksheet. So I press OK in there. So what do I want to do? I want to be able to know whether students' math level, participants' math level are different between gender. So I put gender into the axial, which is different category, because gender is, it's categorical data, right? Math level, it is also, categorical data, but it's okay. We can try this out. So put this in there. And I think I actually want, I want it in here, in here. I don't, yeah. So I want the value to be math level, but it's not sum. I want the values to be count, because math level, it refers to their previous obtained math level, GCSE, A level, and university level. So this is categorical data. It doesn't make sense to produce average. So we use count here. So, and I also need to put math level in here in different series. So I separate, because math level, there are three different, categories. So I want them to be able to separate into different categories. So I let them to have 3 different series. So now we have this table and the bar charts in here, and the row table is gender. So in here you change that to female. Number 2, it's male. Yeah. And degree level, I know the first one, it's called GCSE, GCSE. The second one, it's A level. The third one, it's uni level. So then you got this table in here. Okay, so this is how you do it, how you do, how you compare the differences between groups. Now, the final example refers to research questions that I will demonstrate here is how different the level of confidence in math and computer Excel and Excel by gender. Again, I will do the same using, go back to the data in there. And I want this, I want all of these math and Excel confidence. So I mark all of them and I go to insert. Yeah, and I want pivot charts. And then I go to a new worksheet. Okay, so in a new worksheet, I want to know whether there are differences of these different type of confidence level between gender. So I put gender in here. But if you want to know based on degree level, then you put degree in the Excel. But here we demonstrate gender. Gender and math level, drag it down to the value, can drag it down to the value, and I drag it down to the value in here. And I want, yeah, so that's it. But I don't want sum because sum is not quite representative. I want the average. So I change that to average. Change the second item, its value into average. And I change the third item, its value to average. So now I have this table, and then you go to here to change these to female and then these two male. Yeah, so now you have your table. You probably need to organize it when you are presenting your results. Okay, so I hope it's clear. And now let's move on let's move on to the slides here. So the next slide shows, so how do you present your results of descriptive analysis? This will link to your assignment main body section 2, so you're only describing your results, yeah? And the link there will lead you to look into more details about assignment structure. But today we focus on, first of all, when you describe your data, you first describe basic demographic figure. You could use tests or you could use a table. So if you use tests, you describe something like there were 44 participants in total, and 41 of them aged less than 23, and 3 of them aged between 25 or less than 35, and then keep describing their math levels in terms of how many of them, or you use a table to describe them. The next one, so then you present your data according to your research questions. So here the first research question would be, how confident are students in math and computer and Excel? So you use a table like that. It's clear. You could organize these, but important. Label it and title it, yeah, and make a note so people understand what these numbers mean. But it's important that you present average and standard deviation. Yeah. The second one is how confident of the obtained math level between male and females. So I would suggest that you only present either a figure or a table. Don't present both because you have limited word count. Just present one. But this is just demonstration. And this is a demonstration for responding to 30 research questions. After you describe that, then you can, illustrating the details about, within female, majority of females are, more confident in their, more female students who are confident in computer than in math and Excel. So that's the figure in here. So you could compare within female and within male, or compare across female and male. So I will let you do a practice on research question form. And if you would like to use SPSS, data will be entered in data view. Again, definition of each variable will be entered in variable view. There are different type of variables. You got to code these variables first. And then if you wish to use SPSS and you have SPSS software, then please look into this online tutorial here. It will be very detailed, but you'll be spending a lot of time on dealing with this. You haven't practiced that before. But once when you get it, it's so quick and very functional, much more functional than Excel. So this is the end of this lecture, and I hope this is helpful for you and taking good care of yourself. Bye. Bye.